Hey y'all, you ready for part 3? Okay, here we go. Oh yeah, it's this. But you are the real Florence Nightingale. Okay, so a doctor orders potassium chloride 20 milliequivalents to be added to 1 liter of normal saline to be infused over 4 hours. The medication is available in vials containing 2 milliequivalents per milliliter. Calculate the volume needed to prepare the infusion, and then you got to calculate the milliliters per hour. First of all, I know some of you kind of took a when you saw milliequivalents, but look, they cousin to milligrams. It's not going to make you do anything different in this problem. But whenever you're talking about electrolytes like potassium, sodium, yada, it's always going to be in milliequivalents because that's how they're done. That's all I'm going to say. So he wants 20 milliequivalents. That's what he wants them to get. And we got to add it to that liter of fluid. But we got to find out how much we have to pull out of the vial. And it says the vial contains 2 milliequivalents per 1 ml. Now, that's not saying the vial only has 1 ml. It's telling you the concentration of that vial. So this is going to be this divided by that times that, okay? 20 divided by 2 equals. And that is good. And then times 1 would be still 10 milliliters. We got to pull out of the vial. And we have to add that to the 1 liter of fluid. 1 liter is 1,000 milliliters. And we add 10 milliliters to it. Our total volume is going to be 10 milliliters. We have to calculate the infusion rate in milliliters per hour. And that formula for milliliters per hour is the total volume divided by your time in hours. So our total volume is 10 mLs. And how long's it got to go over? 4 hours. 4 hours. And then we're doing the math. This divided by that. So 10 divided by 4 equals 20. It'll be 252.5. That 5 will round that up to a 3. So 253 milliliters per hour is what we'd set the pump at. You see that? Help him see it, Lord. He's going to help you. All right. Now, this one. I know I wrote all over it. The order states vancomycin 15 milligrams per kilogram for a patient weighing 80 kilograms. The medication is available in vials containing 500 milligrams to be diluted in 100 milliliters of normal saline. You got to calculate the total dose required for Homer and then determine how many vials are needed and then how much saline it's going to take. So this, let me just clear this up. This 500 milligrams is a powder. And you have to put 100 milliliters of normal saline in there to be able to reconstitute the powder. Okay? This right here, this 15 per kilogram, he wants every kilogram to get 15 milligrams, and we got 80 of those kilograms. So we're going to do 80 kilograms times 15 milligrams. Okay, 80 times 15 equals. You see, that's just your straight old 1,200 milligrams. And so that would be the total dose required for the patient. Now, It says determine how many vials are needed to prepare. Each vial has 500 milligrams in it. So if we have 1,200 milligrams, we need to know how many of the 500 milligram vials we'll need. And so I'm going to divide 1,200 by 500. 1,200. I want to know how many 500s are in 12. Divided by 500 equals. And that's going to be 2.4 vials that we're going to have to use to be able to give this to him. So how many vials are needed? 2.4 vials. You with me? I believe you are. Okay. And then you got to calculate the volume of saline needed to dilute the medication. And this says the 500 milligram vials are to be diluted with 100 milliliters of normal saline each vial. How many do we need? We need 2.4 vials. And if each vial needs 100 milliliters, we can multiply this to tell her times 2.4 what the total number of milliliters is going to be required to do all the vials we need, and it's 240. You see that? Help him see it, Lord. He gonna help you. Okay, and then this is the last one. Patient, well, no, Mr. Main, the physician, orders a sliding scale insulin regimen for a patient whose blood glucose levels are as follows. Okay, so this is the scale. And this is for the AC and HS AccuChecks that they do on a type 1 diabetic person. They get them before each meal to check it. And then we got to come here, and if it is between 150 and 200, they got to get 2 units of regular insulin. 201 to 250, 4 units. 251 to 300, 6 units. And then 300 milligrams, we're going to give him 8 units. Okay. So this patient's current blood glucose level is 275. Calculate the insulin that you got to administer. 275 is going to fall between 251 and 300. And so he's going to have 6 units of regular insulin. That would be your answer. Okay? All right. Y'all please like this video and comment, share it, share it with everybody you know. And please, this is my YouTube, at the Nursing Tutor 621. Y'all go over there and subscribe. You ain't never got to go back again if you don't want to. I mean, all the videos on here are on YouTube, and so I just want us to be able to stay in touch. Okay? All right, I believe you picking up what I'm putting down. All right, now go out there and bust an A on this sucker.